Okay. So power القدرة. What is the power? Power, it tells you if you can do the work in short time or you will do it in long time. If you can do a certain work in a short time, that means you have high power. Your power is high. But if you can do the same work but in longer time, that means you have lower power or low power. So power is defined as work done per unit time, work done per unit time, or the time rate at which work is done, or also the rate at which energy is converted or transferred from one form to the other. We said before that if you do work, that means it means you transfer energy to the object or from the object. If you do work, so you give energy to the object or maybe you take energy from the object. So the power measures what? If you do this issue in short period or in long period, like you need to do work, let's say 100 joule of work. If you can do it in 2 seconds, in only 2 seconds, that means you have a power equals, I do the 100 joule in 2 seconds, I have a power 50. But if you do it in 4 seconds, if I do 100 joule in 4 seconds, okay, that means I have a power 25. So if you increase the time, the power will decrease. And if you decrease the time, the power will increase. So again, the power is work done per unit time. The equation is very simple. Work over time or energy over time. Okay? Work over time or energy over the time. Like for example, the charger of your cell phone, the charger or of the phone. There are two kinds of chargers, the normal charger and the fast charger. The fast charger, it has a power of around, I think, 40 or 50, okay, 50 watt. It's energy over time, joule over second. So it's 50 joule over second, which we call it what? Which we call it the watt. So the power has a unit watt. So this fast charger, it has a power rate 50 watt. What does it mean 50 watt? It can give the cell phone, if this is your cell phone, your mobile phone, it gives the mobile phone 50 joule, an amount of energy, 50 joule every second. So every second it can take energy from the electricity, of course, and it gives it to your cell phone, to the battery, to charge the cell phone or to use the cell phone. The charger gives you 50 joule every second. This is the fast charger. The older charger, the older ones like 10 years ago or so, it was slow charger. Its power is much less. It was like around, I think, 10 watt. What does it mean 10 watt? It gives 10 joule, only 10 joule each second. Okay? So which one is better? To give an amount of energy 50 joule per second or only 10 joule per second? Of course, 50 joule per second. Okay? Because you will charge your battery faster. Let's say the battery will need, for example, 4,000 joule, for example. 4,000 joule. This is the capacity of the battery. It will take this amount of energy. Of course, if you give it this amount of energy at a rate معدل 50 joule per second is much better than if you give it the same amount of energy at a lower rate, which is 10 joule per second. So the high power is better than the low power. The same if somebody does a work. If somebody does a work. If he can do it in a short time, that's better than doing the same work at long time, because in the first one, he will have high power. Okay. For motors and engines, we use another unit other than the watt. We use horsepower. Horse power, الحصان. In engines, in motors, or devices and machines that have motors, like the AC, the air condition. Usually the air condition, the power of the air condition is measured in horsepower. Horsepower. The horsepower, 1 horsepower is around 746 watts. 1 horsepower is around 746 watt. So maybe when you buy a car, the engine of the car has a power maybe like 150 horsepower. 150 horsepower. So this is the power of this engine. Okay, and so on. Let's try to solve this one. What is the power when a person does 140 joule of work? So this is the work, 140 joule. And he do it in 20 seconds. So what is the power, guys? What is his power? Huh?
7.
So his power equals the work divided by the time. That's 7 watts. 7 watt. What if he can do the same work at 10 seconds? So his power becomes what? 140 divided by 10. That's 14 watt. So the power increases. Okay, but take care of something, that if the power increases, this guy needs to do a more effort. He needs to inhale more oxygen, so his muscle will work harder. Okay, because he's moving faster and so on. Okay, so he will burn more fats per unit time. Okay, that's why if you are running, you need to breathe deeply and consume more oxygen, because you burn more fat, because you convert more amount of energy per unit time. Like if you are walking, maybe you will burn, let's say, 100 joule per second. But if you are running, you will burn 500 joule per second. Okay, because you will produce more power. Let's try to solve some problems. A motor does 10,000 joule of work in 20 seconds. What is the power? Of course, 10,000 divided by 20. It will be 500 watt. Okay. What do you mean by 100 watt light bulb? Bulb means misbah. Light bulb. What if it is written, when you buy a bulb on the box, you will find it's written 100 watt. What does it mean? What does it mean? Anybody?
Like 130 seconds maybe.
So it takes an energy from the electricity when you plug it in. It takes 100 joule every second. This bulb consumes an amount of energy 100 joule every second. Okay. A 5,000 watt washing machine. What does it mean? This machine consumes 5,000 joule every second. When you plug it in, when you put outlet, or when you put the plug-in in the outlet, okay, it will draw a current, and there is a voltage, of course. So the power consumed is 5,000 joule every second. But take care of something, that the work, the actual work it does, or it exerts, it's not 5,000. It will be less than that. The actual work this washing machine is doing is less than 5,000. Do you know why? Huh? Do you know why it's less?
No.
I think it converts some of the power to the heat power.
Because there is an efficiency. There is an efficiency. Okay? So the efficiency of any machine is not 100%. The efficiency is less than 100%. So this light bulb, for example, it consumes 100 watt. But when you measure the energy of light, it gives light. If you measure the energy of light, it's not going to be the same amount. It will be less. Why? Because there is an efficiency, كفاءة. The efficiency of any machine is less than 100%. Sometimes in this washing machine, it might be 50%, 60%. Okay? In the bulb, it might be 50%, 70%, 80%. Okay? Let's try to solve some problems about chapter 4. A 120 kilogram lawn tractor. This lawn tractor, shown in the figure, goes up 3-meter height on the incline that is 12-meter long. The length is 12 meters. And it does that in 2.5 seconds. So the time is 2.5 seconds. And it does that with constant speed. Speed is constant. What is the efficiency of the incline? Consider this incline as a machine, for example. Like do you remember when we discussed the inclined plane and somebody pushes a box on this incline? Okay, so consider it similar. Let's consider it the same way. What is the efficiency of this incline if the force developed by the tractor is 500 Newton? The force that pushes the tractor up is 500 Newton. So here you need to do what? You need to get the input work and the output work. Input work and output work. What is the input work? It is the force of this tractor times the distance of the tractor. So it's 500 Newton times 12 meters because it moves up 12 meters. What is the output work? mgh. So the output work is mass, which is 120 kilogram times 9.8. The height is 3. So I have output work here. I have input work here. I need to calculate the efficiency. Calculate the efficiency. The efficiency equals what? Output work divided by input work times 100. So 120 times 9.8 times 3 divided by the input work 500 times 12. Do you have calculator, guys? If you have a calculator, could you please do it?
Okay, just a second.
Yes.
$58.8.
58.8%. So this is the efficiency of the machine. Okay? Take care of something. I didn't use the information. I didn't use the time. But I might ask you another question. Like, let's say we are done with this question. Let me ask you another question. What is the input power? What is the input power of this machine?
6,000.
So you will divide the input work over the time. Okay? So you will divide the input work over the time. So the P, the power input, equals 500 times 12. This is the input work divided by the time, which is 2.5. It give you what? 6,000? Huh?
Yes.
6,000 watt. What about the output power here? What is the output power? What is the output power of this incline? I will divide the output work, which is 120 times 9.8.
2,400.
The first one is what?
2,400.
Okay, that's 6,000 divided by 2.5.
Yes.
2,400 watt. This is the input power. And the output power I will divide the output work divided by 2.5. The result should be, can you do it? $1,411.2 watt. So I might ask you about the power, input power or output power. Okay, guys? Let's check the ball swinging freely in a plane. Ignore friction and air resistance, of course. What is the maximum speed of the ball? Maximum speed happens when at the bottom here. This is the maximum speed. Give me a second. So this is the maximum speed here. Let me call it position A and position B. I need to find the maximum speed. So this problem is conservation of mechanical energy. Mechanical energy at point A equals mechanical energy at point B. Why conservation? Because he ignored friction and air resistance. So I will say mechanical energy is mgh plus half mv square at point A equals the same at point B, mgh plus half mv square at point B. At point A, the speed is 0. You need to know that at the maximum height of the pendulum, the speed is 0. So at point A, this part is 0. And at point B, there is no height. The height is 0. So height B is 0. So I will cancel this one also. So easily mgha equals half times m times vb square. Of course, usually I cancel the mass with mass. So g times ha, the height at A equals 2.5 meter, equals 1/2 divided, times the VB square. And of course, VB is the maximum speed. So I can consider it Vmax. This one is 9.8. So V equals what? Root of 2 times 9.8 times 2.5. What's the result, guys? I think 7 meters per second. Got it?
Yes, sir. 7.
Okay. Let's see this one. A bead of mass is released at point A. You release this ball of mass m. Release it means it has initial speed 0. Let's say this is VA at point A. And slides on a frictionless track. So when he says frictionless track, so he wants us to use the conservation of energy. What is the bead's speed at point B? Where is B? B is here, when it reaches here. So I say the mechanical energy A equals mechanical energy B. So mgha plus half mva square. This is the mechanical energy at A, equals the same at B, mghb, the potential energy, plus the kinetic half mvb square. Of course, we can remove the mass m, and also the initial speed is 0, so we can cancel this one. So the leftover is what? G times HA equals G times HB plus half times VB square. We are looking for what? The speed. We are looking for the speed VB. So take GHB to the other side. It will be GHA minus HB. Right? I took the G as a common factor. Equals half times VB square. So you can take the half to the other side, which is 2 times the other part. And if you want to remove this square, you can take a square root. Okay? You understand it? So I will take a square root here. So VB equals what? Root of 2 times 9.8 times HA minus HB. 5 minus 2 is 3. 3. So that's almost 7.
7.66.
7.66 meter per second. Okay, 7.67. Understand it? Good. Let's see this one. Before we read this one, I need you to remember. I need you to remember that the kinetic energy equals what? Half mv square. Half mv square. So if the speed increases 2 times, what will happen to the kinetic energy? We discussed this issue last time in the previous lecture. If the speed increases, if the speed of the object increases 2 times, so the kinetic energy increases what? 4 times. 4 times. If the speed increases 3 times, the kinetic energy increases 9 times.
9 times.
So if the speed increases whatever n, the kinetic energy will increase n square. 2 times, 3 times, 4 times, it will be whatever n square, right? Do you agree about that? Of course. And vice versa. If I tell you the kinetic energy changes n times instead of n, let's make it, I need another symbol. L time, L, I don't like L. X times. The kinetic energy changes X times. So the speed will change what?
Square root x.
The root of x. That's right. Root of x. Okay. So it's the opposite exactly. If the speed increases whatever number n, 3 for example, you square it, becomes 9. Okay. But if the kinetic energy increases or changes x times, which is 9 times, the speed will be the root of 9, the root of x, which becomes a 3. You agree about that?
Yes.
Good. So we agree about this idea. A ball of mass m rolls along a flat surface with a speed vi. So it has a speed vi. It strikes a padded wall and bounces back. So it will strike the wall and it bounces back. Okay. In opposite direction as in the figure below. The energy of the ball after striking the wall is half of its initial energy. Which energy is he talking about? Which energy? Mechanical energy, kinetic energy, or potential energy, or what? Actually, he's talking about the mechanical energy. He's talking about the mechanical energy. But in this problem, I don't have a potential. There is no potential because object moves horizontally. So there is no potential. So he's talking about the mechanical, and essentially there is no potential. So he means the kinetic energy. So he means the kinetic energy in this problem. So the kinetic energy, when it comes back, let's say at the beginning, the kinetic energy is kinetic energy 1. When it comes back, becomes kinetic energy 2, which is half the initial kinetic energy. So kinetic energy in the second case is half the initial kinetic energy in the first case, or half the original kinetic energy. Okay. Ignore friction. Good. So we can conserve energy if we want or whatever. Which of the following expression gives the ball's new speed as a function of its initial speed? That's very easy. I need a relation between the new speed, v final, and the initial speed, v initial. What do you think?
Root 1/2.
The kinetic energy becomes 1/2. So the speed will be root of 1/2 of that v final of the initial speed. So it will be the root of the change, the root of 1/2. What's root of 1/2? Actually, it's root 2/2. Like root of 1/2 equals 1/√2. And then I don't know why he did that, but he did it actually. He multiplied it in the numerator and denominator by root 2. So 1 times root 2 is root 2, and root 2 times root 2. So it's this one. Okay? Understand it? Get it?
Yes.
Okay. Let's see some other idea. A 0.25 horsepower motor. Horsepower, we just said the horsepower is what? Is 746 or what? You remember? What? Around it. We said it was what?
I guess the value.
746 watt. Almost 746 watt. So actually he gave it to you at the end of the problem. Oh, that's good. You are lucky. Oh, I mean, they were lucky. A 0.25 horsepower motor is used to lift a load at a rate 5 centimeter per second. So this is the speed. I don't like centimeter per second. How much meter per second is it? The 5 centimeter per second is how many meters per second?
0.05.
Divided over 100. Divided over 100. Okay, so it becomes 0.05 meter per second. So we have a motor that lifts a load up at this speed. How great is the load, or how great a load can it lift at this constant speed? We need to find the mass. He's asking about the mass. So find the mass of the object to lift it up. What do you think? What do you think? Gives you the power. The power equals 0.25 horsepower means times 746 watt, or joule per second, whatever you want to say it. This is the power. And I know the speed of the object, and I need the mass of the object. The power equals what? The work divided by time. right? Power equals work over time or energy over time. So here I need, what is the work that you need to do? You need to lift a certain mass upward. Okay. What is the work done on a mass to lift it upward? We studied this one in the work 2 lectures ago. To lift a mass against gravity. What is the work done? Equals what? A work done to lift a certain mass against gravity, a certain height h. mgh. mgh. So this is the work needed to lift a certain mass, a height h. And the power is work over time. So the power equals this work divided by the time. Right? Work over time. The mass, this is what I'm searching for. G 9.8. But he doesn't give me any height or any time. But he give me the speed. And he give me the power. So how should I behave in this problem, guys? Do you have any idea? Knowing that the speed is constant speed.
Maybe I
Go ahead, Sultan. Huh? What do you say? Huh?
Me?
Yes, yes.
Maybe we separate the speed, time and distance.
Okay, that's a good idea. It's a constant speed, 0.05 meter per second. That means every 1 second, every a time equals 1 second, you can lift it a height h equals 0.05 meter. That's what you want to do?
Yes.
Okay, good. That's a good idea, actually. It's a good idea. Like you say, every 1 second, you move the object up a certain distance, 0.05 meter. And then you can substitute in the equation and you will find the mass. Okay, that's a good one. Or you can say what? mg h over t. What's h over t? It's the height divided by the time. What is it? You are moving with constant speed. So this is the speed, actually. This is the speed. So it's mg times the speed. Because you are moving with constant speed. So h over t, distance over time, gives you the speed. So the power equals mg times v. Power is 0.25 horsepower times 746, the conversion factor, equals the mass, I'm looking for it, times 9.8 times the speed 0.05, then I will find the mass 381 kilogram. You understand it, guys? So we can use what Turkey says. We can say at a time 1 second, the height will be whatever. Or I can say because of its constant speed, so height over time is the speed. Two marbles. One twice as heavy as the other. So one of them, let's say the first has a mass m, the second one has a mass 2m. So one is twice heavy as the other. Are dropped to the ground from a top of a building. So they are dropped from the top of a certain building. Just before hitting the ground. Just before they hit the ground. The heavier marble has what? Without looking to this stuff, I don't care about what he's giving. The heavier marble, he might talk about the speed. He might talk about kinetic energy. What do you think? What do you think?
Before
He
maybe.
might talk about total energy. When they reach to the ground, when they reach to the ground, which one will have more speed? Which
gonna
one will
be the
have
same.
more speed?
The heavier one.
They will be the same. They will have the same speed. They will have the same speed. Why? Because
Free
the
fall.
speed depends on what? That's a free fall. The free fall does not depend on the mass. Okay, it's free of the mass. V square equals V initial square plus 2GH. Where is the mass here? There is no mass. The final speed depends only on the initial speed, which in our case is 0. So it depends only on the height and the gravity, of course. Depends only on the height, and as long as they are dropped from the same building, so they have the same height, so they will have the same speed. Okay, that's a good point. But do they have the same kinetic energy? You said they have the same speed, but do they have the same kinetic energy? Kinetic energy is what? Half mv square. Half is the same. Speed is the same. But what about the mass? This one is bigger than the other, so I expect the bigger one has double the kinetic energy. Double the kinetic energy. Let's now look and see what are the choices. The heavier marble has twice kinetic energy as the lighter one. That's right. Same, of course not. 4 times, no. A quarter, ربع, no. 6 times, 6 مرات, of course not. So if he is talking about speed, they have the same speed. But if we are talking about the kinetic energy, so the kinetic energy of the first one or the bigger one is double the other one. Let's solve it using another method. Let's try to solve and get the same idea with another method. What is the method? Conservation of energy. What is the energy of both of them at the beginning? Potential energy. And what is the energy at the bottom? Kinetic energy. They are the same. They are the same. The potential energy at the beginning equals the kinetic energy at the end. mgh equals half mv square. Potential energy equals kinetic energy. You know that? The potential energy at the top equals the kinetic energy at the bottom. You agree about that, guys? Okay. What is the potential energy of the first one? mgh. What is the potential energy of the second one? 2mgh. So the second one has double the potential. So also it will have double the kinetic. You agree about that? Yes. So this is another idea. Let's see something else. 100-kilogram person climbs stairs, gaining 3 meters in height. Like someone climbs the stairs. He starts from here until here. 3-meter height. In just 5 seconds. That's a good one. 5 seconds. So he gives me the height and the time. What is the power of the person? A very, very good, very nice question. What do you think? Somebody, some object, whatever, moves up a certain height in 5 seconds. What do you think? Power? Work over time. What is the work done on the object to lift it up? mgh. Time t. So mass is 100 kilogram, g is 9.8, the height is 3, and the time is 5. Okay, so you can solve it and find what is the result.
588.
Okay, what is it?
588.
You got it. You got it. 500.
Yes.
What? So 588 watt. You can solve the same like the ball that was sliding. I want to see if there is another idea. When reaches to the bottom, that's also conservation. Let's look at this one. Which of the following statement is true? Work doesn't have direction. Does the work have a direction? Does work have a direction? Of course not. Work has no direction. Work is a scalar quantity. Work and energy are scalar quantities. You cannot say this energy or this work is to the right or to the left. Doesn't work like that. But they are scalar quantities. Okay, so work, energy, mass, speed. Okay, all of these are scalar quantities. Okay, but force is a vector. Acceleration is a vector. Momentum is a vector. Impulse is a vector. What else is a vector? Displacement is a vector. Velocity is a vector. Okay, all of these are vectors and they have directions. But work and energy, no. Momentum is a vector. We said momentum actually. Energy and work, they are scalar quantities. Okay, they are scalar quantities. So this one is a true statement. The rate at which energy is converted from one form to another is called the acceleration? No. It's called what? The rate of change of energy. It's called the power. Power is the rate of change of energy. Chemical potential energy is mechanical energy? Of course not. Mechanical energy, it's either gravitational potential, maybe gravitational potential, maybe elastic potential, gravitational potential or elastic potential energy, or kinetic energy. Kinetic energy or potential energy, but the potential must be, it's either gravitational or elastic. Okay. Bicycle is a simple machine? Of course not. Bicycle is a compound machine. Okay, guys? Let's try this one. If a runner's power is 400 watt, the power is 400 watt, which is joule per second, He runs, okay, how much chemical energy in calories? Calorie is a unit for energy. And here he says 1 calorie equals 4,000, almost 4,000 joule. So he converts into other forms of energy in 10 minutes. How much energy? I'm looking for the energy during a time 10 minutes. 10 minutes means how many seconds? 60 seconds. 10 minutes is 60 seconds. I know that the power equals energy over time.
In 600.
So I will say
Yeah.
400
600.
joule per second. 600, yes. I'm sorry, 600. So 400 joule per second equals energy, which I don't know what is it, divided by the time, which is the 600 seconds. So I can find the energy equals what? 240,000 joule. So I find the energy in joule because the time here is second and the power is joule per second. So he asks what? I need the chemical energy in calorie. How to convert it into calorie? He said 1 calorie is 4,000 joule. So the energy in calorie equals what? The 240,000 joule divided by the conversion factor here, 4,000. 60 calories. So 60 calories is the amount of energy. Okay, guys? So that's enough. I have solved some other problems in another video, and I have uploaded the other video to the Blackboard today. So I will upload this video also. Okay, and you will find both on Blackboard today, inshallah. Okay.